the construction and the development is made in 3 dimensions, so I can move the whole movement. I can see inside. I can like take off a bridge to see what's happened in the gear train. We can check the escapement. So that's the good thing on 3-dimensional developments. I work with 2 different CAD softwares. First I have one software is more for the construction, for building the parts. It's pure more research development part. And then another one which is more for the designing the watch, so we can choose different finishing, we can choose different materials. I can also say, okay, I want to check if the perlage fits better on this surface, and then modify it. Also see if how big the perlage has to be.
That opens a lot of options, of course. And have there already been clients that say, oh, this looks cool, but could you change this or that?
In the history of Armin Strom, we were always producing customized pieces, and some of our customers, they come especially to the workshop in my office to build up their own watch. So they want to have their own finishing. They want to try different colors, and then we're sitting together. We are looking how the finishing could be. We cannot do like the engravings, but we can do the polished bevels. We can see if it's better if it's polished, if it's matte finished, if it's a Geneva stripe or a perlage or a blue coloring or a dial or an orange coloring. So we can go very far in customizing pieces, because everything is made in-house. So we can even change the shape of a bridge if a client wants to have a different kind of skeletonizing. So I can first then build the skeletonized bridge, bring it to the rendering software, and put different surfaces. Different in Armin Strom is that design and development is like a more parallel process. So we are not doing the development of the movement, and once the movement is made, we do the design. So it's a bit more of a parallel process. So we do a little bit of development of the movement, and then we are already thinking about how the bridge or the wheel will be at the end product. So it's more like a parallel process. It's not like engineering and design separated. The movement is part of the design, it's part of the whole face of the watch. So Armin Strom, we are not just showing a bit of a mechanical movement, so the movement becomes design. The whole architecture of the movement is part of the design.
We're just seeing how you designed watches. So can you take us step by step by what is being done downstairs in the machining departments?
Yes, so downstairs in the fabrication we do about 98% of our movement is made in-house. Mm-hmm. So that means we receive stainless steel and brass, and out of stainless steel and brass with 4 different CNC machines we are building the movement parts. So
how many parts altogether do you produce here in-house?
From the movement it's about 98%, so we are not doing the hairsprings, mainsprings and rubies, but we are producing bridges, main plates, screws, wheels. We also do the gear train cutting, from pinions, wheels.
And that is all, what kind of different machines do you use for that and different kind of applications?
So we have 4 different CNC machines. So we have a drilling machine, mm-hmm. We have a milling machine, and then we have a wire erosion machine for cutting out the shapes of the parts, and we also have the gear train cutting machine.
So do you produce big series of watches per model, or is it small series?
In general we are producing small series, so main plates and bridges, let's say it's in between 20 and 50 pieces each. Mm-hmm. And then we have several parts like screws or wheels, which we have a little bit bigger series.
Different machines have different tolerances. How is it with the precision and the tolerances that you are using?
So we have a general tolerance in our in producing our parts is plus minus 10 microns, so plus minus 1/100th of a millimeter is like a general tolerance. and from there we go even smaller to 0 plus 4 thousandths of a millimeter. It's nearly all the parts are nearly 100% controlled because we are spending so many time in doing decoration that we have to make sure that all the parts which are going into the decoration workshop are perfectly made.
So before the watch is being assembled, it really has to be perfect, because after the finishing and the decorations, etc., you can't do anything to adjust, for instance.
No, we can't.
So
we have to make sure that from the beginning the watch, the part, let's say a main plate or a bridge, has to be in tolerance, has to be the right dimensions when the part comes out of the machine. Because imagine a main plate, it takes about 2.5 hours to produce the main plate on the CNC machine, but in the decoration workshop it can take up to 5, 6, 7 hours of decoration.
Is there an optical control after producing?
We have two kind of controls. So there's one quality control, is like where we take the measures of the part. So we need to make sure that the tolerances, that the part is built in the tolerances, technical measuring. And there's also a visual control. A visual control that the parts are perfectly made, that there is no scratches on the part and I think no damages. So we have to make sure that each part is perfect out of the machine. This is our galvanic kitchen. So we have different kind of bases. We have different kind of metals which we are using for our galvanic treatments. We are using a pre-gold layer, which is quite special. It's quite a unique thing because we want to cover the brass, the nicely finished parts from the nickel. The nickel is quite an aggressive metal, so we want to cover our nicely done, perfectly finished parts from the aggressive nickel, pre-gold. Then we do the nickel treatment, and on each nickel we also put either a gold or a rhodium or ruthenium layer. This is then color giving at the end.
Why is the nickel treatment done in between?
The nickel treatment is for the handling for the watchmaker, so nickel makes the part a little bit more stable, a little bit harder the surface, so it makes it more easy to handle for the watchmakers.
Okay. What kind of the different finishes are the finishes that Armin Strom offers?
Color-wise, we have the rhodium, which is quite a clear metal. We have the ruthenium, which is a dark metal, dark grey metal. Then we have yellow gold and rose gold. The hand finishing is something very important for us because the movement which is visible from the front as well as from the back side has to be finished on a very, very high level. Already our founder, Armin Strom, which did the skeletonized movement, so the skeletonized movement, you see all the details, he was very known for the finishing, for the hand finishing. So this is what we still do on all our watches. The parts are built by CNC machine, but they are completely decorated by hand. So it could be either a hand bevel, the bevels are polished by hand, we have hand engravings, we use the Geneva stripes, perlage, so we have like 10 or 15 different kind of finishings we are using on our parts.
Different materials have different resistance and different ways to finish it. I can imagine that on a piece of brass you need different force to do a certain finishing than on a piece of metal.
Exactly, yeah. So brass, it's one reason why we use brass for main plates and bridges is because brass is quite, we have the best polished bevels gets on brass. We have the Geneva stripes which are very nice, come very nice on the brass. Also for the hand engraving it's a very nice metal compared to steel or titanium or aluminium. Yes, this is the classic watchmaking workshop. So the watchmakers, they are doing their pre-assemblings. So we have different steps what we are doing in the watchmaking workshop. We have the pre-assemblings. So pre-assembling means we put the stones in the main plate and bridges. We also do the pins and pillars we are putting in those bridges. We also do like putting wheels and pinions together, so what we call the pre-assemblings. The pre-assemblings, they're always made in series of 20, 50 or 100 pieces, and after that the pre-assemblings, they go back in stock, and from the stock they come back in the workshop, and then there's the final assembling of the movement. So once the movement is assembled, we have to do different tests. First of all, we test the movement with the accuracy, the power reserve, how precise the movement is. Once the movement has done all the final tests, then what we call is like the wedding. The wedding means we put the hands and the dial, and we put the movement in the case, and then the whole process begins from the beginning. So all the tests, we have to redo all the tests. We have to
approximately how long does the first phase and the second phase?
A movement takes about 2 weeks, and then once it's in the case, there's another 2 to 3 weeks we check the watch.